Hi students, I'm going to be going through some of the questions with regards to altering concentration that you had in the tutorial class, and I want for us to be able to go through it step by step so that you understand where you would have gone wrong if you got it wrong. And you can always go back on Moodle to check your responses. So let's go. So the objective of the tutorial session was for you to be able to perform calculations to alter the concentration of a mixture after collaborating with your peers, consulting your notes and textbooks, and completing a short quiz using the concepts of ratio and proportion, alligation, arithmetic methods with 100% accuracy, and of course without assistance. So let's see how well you did. The reading assignments, of course, are stated here. I'm encouraging you all to go to the text, look at the chapter, and look at the questions at the end of the chapter. I would like to remind you that the answers to the questions are there. And if you are having any challenges, reach out to your peers. If it is that you still don't know how to arrive at the answer, then you can always have a consultation with me. Okay, so the first question is a prescriber orders cefprozil 7.5 milligrams per kilogram every 12 hours for a week for an upper respiratory tract infection for a patient weighing 44 pounds. The pharmacist has on hand cefprozil dry powder for oral suspension, and we're going to be using the label in the figure above to answer the questions that follow. And the questions are: 1. We're going to calculate the dose for the patient that they will take each time, that is the single dose. Determine the amount of drug, pure cefprozil, that's contained in the dry powder. Determine the volume of the suspension the patient needs to take each time if the dry powder is reconstituted following the label instructions, and to determine the number of bottles needed for the drug regimen. The doctor requests that the dose be placed at 5 ml. Using the label instructions, calculate the amount of water that must be added to the bottle to obtain the dose in 5 milliliters. Okay, so what is it that we first need to do? The first thing that we need to do is to look at the label. And remember, from the last lecture, the label will give us quite a bit of information. The label will tell us what the concentration of the suspension will be once you reconstitute that powder. It will also tell you how to reconstitute the powder. And also, it will tell you the final volume of the suspension once you reconstitute the powder. And all of that information is here. So we know that we have to add 70 ml of water to the powder to end up with a final volume of 100 ml, and the final concentration is going to be 250 milligrams of cefprozil in every 5 ml of that suspension. So that's the groundwork. So we write that down. Then we now look at the questions. The first question says that we are to calculate the dose for the patient. Now this is pretty straightforward. You have the weight of the patient in pounds. It's 44 pounds. You'll have to convert that to kilograms. You got 20 kilograms. And then you look at how the thing is dosed. The dosage regimen states 7.5 milligrams for every kilogram body weight every 12 hours. But the question is asking for the dose the patient will take each time. So that means it's a single dose that you're calculating. And the single dose is going to be 7.5 milligram per kilogram times 20 kilograms, because the patient's total weight is 20 kg. And of course, the dose is going to be 150 milligrams each time. The second question asks, determine the total content of pure cefprozil that will be contained in the dry powder in the bottle. How are we going to do this? We have to use the information that's given to us. The information that's given to us is on the label. Again, it's saying that once you reconstitute the powder, you're going to have a final volume of 100 mils, and that suspension is going to have a concentration of 250 milligrams every 5 mils. So, if you know what the final volume is, and if you know what the concentration is, then you can determine what amount of the cefazil will be in the powder. Even though you have not yet mixed it, the information is given to you. So, if 250 milligrams of the drug is contained every 5 mils, according to what the label is saying, and because we know that once we reconstitute, we're going to get a final volume of 100 mils, then we can determine what would be the amount of drug in that final volume of 100 mils. And we got 5,000 milligrams, right? Okay, so we have found that the final amount, the total amount of cefazil in the final volume of 100 mils, once you follow the manufacturer's instruction, would have been 5,000 milligrams. So we determine the dose, the single dose. We're able to determine the amount of drug in the powder. And I just like to state here that that powder that we see in these bottles is not just the active ingredient. It has active ingredients plus other ingredients, excipients we call them. So sucrose, starch, binders, all these other things that make up the suspension will also be in that powder. Just to recall that reconstituted powders are made by making the suspension at first, and then you remove the vehicle from it. So what's left behind is the powder. Okay? And that powder will contain not only the active pharmaceutical ingredients, but other excipients as well. Let's go to the next question. Alright, so we are at number 3. Number 3 says that we are to determine the volume of the suspension the patient needs to take each time if the dry powder is reconstituted following the label instructions. And we are also to determine the number of bottles needed for the drug regimen. I'm going to leave that for you to decide, but I'll calculate the volume of suspension the patient needs to take each time. Okay, so we're following the manufacturer's instruction here. So that means we're going to add 70 mils to the powder, do a little shaky shake, and we're going to end up with 100 mils of suspension. That means that the concentration is going to be 250 milligrams per 5 mils. But the patient is to take 150 milligrams each time. So therefore, we are going to have to determine what volume of this suspension is going to contain 150 milligrams. Of course, we start from what is known. We know the concentration. Every 5 mils contain 250 milligrams of the drug. Therefore, 150 milligrams will contain X, and X will be 3 mils. So that means the patient is going to have to take 3 mils of the suspension, which is what we typically do in the normal setting. However, there are times when you're going to have to dilute, which we'll see in question 4. Now, do you think that you can determine the number of bottles that would be needed if you're going to follow the instructions of the manufacturer to supply the drug regimen of 1 week? Let's see what answers you will get. Okay, so the 4th question says that the doctor requests that the dose, remember that dose, 150 milligrams, should be contained in 5 mils. And you're to use the label instructions and calculate the amount of water that you need to add to the powder now to get that concentration. The manufacturer stated that the concentration, when you follow their instructions, will be 250 milligrams per 5 mils. but the physician wants you to put the dose that the patient is going to take, which is 150 milligrams in 5 mils. So we can definitely see that we are going to have to dilute that 250 milligrams per 5 mils in order to get 150 milligrams per 5 mils. Now, we need quite a bit of information. We need to determine the volume that the powder is going to occupy, because this is important in determining the amount of water to add. Because if the powder is occupying some amount of volume, then determining that is going to help us to determine the amount of water that we will add, separate and apart from the water that the manufacturers are telling us to add. I decided to use the CSVS, but you can use ratio and proportion to see if you will arrive at the same answer. Now, the dose, as we said, is 150 milligrams. Physician wants to be 5 mils. Using the CSVS method. CS, we know it's 250 milligrams per 5 mils. That's concentrated stock in inverted commas. VD is 100 mils, because once you make that suspension as directed by the manufacturers, you're going to get a final volume of 100 mils. CD is what the physician wants. He wants 150 milligrams per 5 mils. But we don't know what the volume is, because we're going to dilute it, but we're going to dilute the original suspension, but we don't know what that final volume is going to be. So, 250 milligrams per 5 mils, the concentration, times 100 mils, divided by 150 milligrams per 5 mil is going to give us VD, because we're solving for VD. And that final volume, once we dilute the stock, we're going to end up with 166.7 mils, roughly 167 mils. So what does this mean? It means then that I'm going to add sufficient amount of water to the powder to end up with a final volume of 166.7 mils that will now have a concentration of 150 milligrams per 5 mils. Well, how much water do we need to add? That's where the volume of the powder is going to come in. Recall that the manufacturer said that we're to add 70 mils of water to the powder to end up with 100 mils. Simply means that the powder is occupying a volume of 30 mils, because we end up with a final volume of 100 mils when we add 70 mils. So therefore, if we know that the final volume occupied by the powder in the mixture is going to be 30 mils, then we can determine the total amount of water that we need to add to get to our concentration of 150 milligrams per 5 mils. So we subtract 70 from 100 to get the volume occupied by the powder, which is 30 mils. Subtract that 30 mils now from 166.7, and we end up with 136.7 mils. Pretty simple, but it requires for us to reason and write down the information that's available to us. So how does this look practically, or in a practical sense? It means we're going to retrieve that bottle with the powder from the shelf. We're going to add 136 mils of water to that powder, give it a little shake, and we're going to end up with a final volume of 166.7 mils. And that 166.7 mils is now going to have a concentration of 150 milligrams per 5 mils, which we will now give to the patient. So that's exactly what it means, and that's what we would have done in practice. Okay, let's go to the next question. Okay, ladies and gentlemen, we are at question 2, and we're given a formula to make 30 mils of a solution that will contain tetracaine hydrochloride, 0.175% weight in volume, 1 in 4,000 weight in volume of epinephrine hydrochloride, cocaine hydrochloride 3%, and we're adding all of this up to a volume of 30 mils. And you are required to find how many milliliters each of a 2% weight in volume solution of tetracaine hydrochloride and a 1 in 1,000 weight in volume solution of epinephrine hydrochloride should be used in preparing the prescription. So let's look at determining the amount of tetracane hydrochloride we will need. Now we need to look at this formula, and this formula tells us a lot of information. It tells us, in terms of tetracane hydrochloride, the final concentration that would be in this solution of 30 mils. It's saying that this 30 mils, once you have made it, you will have 0.75% weight in volume of tetracane hydrochloride. So we then need to make the 30 mils. Can't exactly go to a scale and weigh 0.75% weight in volume. It's only telling us the concentration. We need to know the amount so that we can weigh or measure, if it is a stock, of the amount of tetracane hydrochloride we need for 30 mils. So using the concentration, 0.75 grams is in every 100 mils. Therefore, the amount that would be in 30 mils would be 0.225 grams. Again, when you get this information, what is it about? This 0.225 grams of tetracane is going to be contained in that 30 mils, and that is going to give the concentration of 0.75%. Now, you need this amount of tetracane to make the 30 mils. Where are you going to get it from? You can get it from two places. Either the pure drug, you're going to weigh 0.225 grams, or you're going to get it from a stock solution. When we look at the question, we see that we don't have the pure drug, we have a stock of 2%. So it means then that we need to find what volume of this 2% tetracane solution will furnish us with the 0.225 grams that we need to make the 30 ml of mixture. So, coming from the concentration of the stock, 2 grams is in every 100 mils. Therefore, what volume will contain 0.225 grams? And we find that out to be 11.25 mils or 11.3 mils. That means we're going to measure 11.3 mils of a 2% tetracane hydrochloride solution and use it to make this 30 mils of mixture that we want, and it will give us a final concentration of 0.75%. Similarly, for epinephrine hydrochloride, we have to use the 1 in 4,000 to determine what amount of epinephrine HCl will be in the 30 mils to give us that concentration. So if 1 gram is found in every 4,000 mils, then we can find out what amount of grams of epinephrine will be in 30 mils, and we find that to be 0.0075 grams. Where are we going to get the epinephrine? Either from a pure source, that's a pure drug in its powder form, or we get it from a stock solution. In this case, we have a stock solution of 1 in 1,000. That means that we can determine now what volume of that 1 in 1,000 stock will provide us with 0.0075 grams that we need. And we find that out to be 7.5 mils. That means you're going to take 7.5 mils from the 1 in 1,000 solution. That will furnish us with the amount of epinephrine we need to make this 30 mil stock. We were not told about any stock for cocaine, right? It may be the powder, but whatever the case may be, we're going to take these two volumes, the amount of cocaine that we're going to need to make 3%, and then we're going to add up all of that to a final volume of 30 mils with sodium chloride solution. Alright guys, so let's look at question 3. So we have the formula there, cyclosporine 2%, corn oil, we're going to add up to a sufficient amount. And we're going to use as directed as the signatory is indicating. There are two questions here. A, how many milliliters each of the corn oil and a 10% weight in volume solution of cyclosporine will be needed to prepare 30 mils of the prescription. And if you wish to dilute the solution to a concentration of 1.5% cyclosporine, what's the additional corn oil that you're going to be adding? So, let's look at part A. So let's determine the amount of cyclosporine first, because the cyclosporine that we see in this question is a solution. Corn oil we know is a liquid, so it makes sense. This is the only way we are going to be able to determine the corn oil, because the corn oil we add sufficient amount to whatever volume we wish to make. So the amount of cyclosporine that we have to determine is now going to be dependent on the final volume that we need to make, which the question tells us, which is 30 ml. Now, looking in the formula, cyclosporine will have a final concentration in whatever mixture you're making to be 2%. In this case, we're making 30 ml. So the 30 ml, you need to determine what amount of cyclosporine is going to be in that 30 ml, given that it will have a concentration of 2%. So this means that if 2 grams of cyclosporine will be in 100 ml of the mixture you're trying to make, or 100 ml of the mixture, 30 ml of the mixture you're trying to make will contain X, and X is going to be 0.06 grams. So it means in order for you to make 30 ml of cyclosporine mixture that will have a concentration of 2%, you will need 0.6 grams. Again, we always go back to this. Where am I going to get my 6.6 grams from? Am I going to get it from a pure powder? Go to the scale and weigh the 0.6 grams? Or am I going to get it from a solution? We're going to get it from a 10% stock solution. So we need to find out what volume of this 10% stock would furnish us with 0.6 grams. So if 10 grams is in 100 ml, then 0.6 grams will be in X, and we get 6 ml. So therefore, because we are making up to volume with corn oil to 30 ml, then we can determine the exact amount of volume of corn oil that we're going to add. So we just simply subtract the 6 ml that we will get from the 10% stock to furnish us with the cyclosporine we need, and subtract that from the final volume of 30 ml to get 24 ml, which will be the amount of corn oil to add. Okay, so let's look at part B. Part B says that you wish to dilute the solution, which is a 30 ml solution you had made before, and make a concentration of 1.5% cyclosporine. And you want to know how many additional milliliters of corn oil will you need to add to the 30 ml to get that. So we need to prepare 1.5% of cyclosporine, and we are going to be diluting all of the 30 ml 2% solution that we had calculated or prepared in part A. We know the amount of cyclosporine that will be contained in this 30 ml. We calculated before in part A to be 0.6 grams. If we know the final concentration of the diluted cyclosporine solution we want to get, then we can determine what volume, based on that concentration, 0.6 grams will be contained in. So if 1.5 grams of the drug is contained in 100 ml, then 0.6 grams will be contained in X ml of the mixture. So X is going to be 40 ml. So it means then that the 30 ml we had calculated in part A will now be diluted to get a final volume of 40 ml. And we need to know what volume of corn oil would we need to add to the 30 ml to get 40 ml. It's very obvious. We have to subtract the 30 ml from the 40 to get 10 ml. So it means that we will add 10 more ml of corn oil to the 30 ml that we had before to get 40 ml, which now leads that mixture to have a concentration of 1.5%. Okay, so question 4 says, how many milliliters of a 2.5% weight in volume chlorpromazine hydrochloride injection and how many milliliters of the 0.9% weight in volume sodium chloride injection should be used to prepare 500 ml of a concentration now of 0.3% of the chlorpromazine? Now, we want to make a 0.3% chlorpromazine mixture from 2 mixtures. one that contains 2.5% chlorpromazine and one that has no chlorpromazine in there. As a matter of fact, it's just the vehicle, even though it has a percentage concentration of 0.9% sodium chloride stated in the question. But we must recognize what is the subject of the question. Subject of the question is we want to determine what it is that we need, how much of these two ingredients we need to mix together to get 0.3% chlorpromazine. So chlorpromazine is what we are working towards. So 0.9% sodium chloride does not factor into the calculation in terms of the amount of sodium chloride, because we're not solving for sodium chloride, we are determining the amount of chlorpromazine. So sodium chloride is now the diluent, meaning it has no drug, no chlorpromazine in there, so it is now treated as 0%. So it means then that we are going to be using the mere fact that we are going to be combining two ingredients together to get a final concentration of another ingredient. We are going to use alligation alternate. So we set up our what you may call it, or well, we set up our calculation in such a way that the concentration we want to determine is in the center, and the other two concentrations are written at the top and the bottom of it. Doesn't matter what order, you can put 0% at the top, 2.5% at the bottom. Doesn't really matter. What matters is that we are going to be determining the parts by subtracting diagonally. So 0% from 0.3 is going to give us 0.3 parts, and we're going to take 0.3 from the 2.5% to give us 2.2 parts. What does this mean? Let's go back. This means that we are going to go horizontally to determine the amount of parts of each of the ingredients. So 2.5%, we're going to use 0.3 parts of it, and the amount of sodium chloride, which represents 0% here, in this case, you're going to use 2.2 parts of it. And it makes sense if you think about it. You're going to use more of the diluent to dilute the 2.5% to give you a 0.3%. So it makes sense. So we add the number of parts, we get 2.5 parts. And then to determine the amount of the 2.5% hydrochloride injection, we determine that 0.3 parts out of the 2.5 parts will be the injection. So you multiply that by 500 to get 60 mL. Similarly, 2.2 parts out of the 2.5 parts will be the sodium chloride injection. You multiply that by 500 mL to get the amount of sodium chloride injection, which would be 440 mL. Alright, so we are at the last question, question number 5. And this question requires us to determine what would be the final concentration of alcohol in a 5-liter mixture if 2 liters of witch hazel, 1 liter of alcohol, and boric acid solution are mixed together. Now the clue here, because students ask all the time, how do you know it is alligation medial? How do you know it's alligation alternate? In terms of alligation medial, what you know, or what will let you know that you're going to have to use that method, is that you're going to be combining lots of, when I mean lots, not number, but different mixtures of varying concentration of a particular ingredient, and you're to determine the final concentration. So the final concentration is always to be determined, and therefore there are lots of things that you're going to have to take into consideration. One, you have to take into consideration what would be the final mixture in terms of volume or weight, and you also have to determine what percentage of the ingredient these other what percentage of the ingredient these other mixtures are contributing to the final mixture. So, in other words, taking this question, you need to find out what percentage of alcohol is which hazel providing the final mixture, what percentage of 95% alcohol, the 1 liter, what is it, how much alcohol is it giving to the final mixture, and the boric acid. So when we look at which hazel, we notice that 14% of alcohol is contained in that mixture. So 14% of 2000 ml will give us 280 ml. What does this mean? That 280 ml of pure alcohol is going to be found in that 2000 milliliters of witch hazel. 95% alcohol solution was also found in this mixture. So 95% of 1000 ml is going to give you 950 ml. That means it's 950 ml of pure alcohol in the 1000 ml mixture. And of course, boric acid solution is also in the mixture. But again, is boric acid speaking directly to alcohol? No, it's not. It has boric acid in there, yes, for sure, but it has no alcohol. The question didn't say that it did. So we assume that boric acid solution will contain no alcohol. So it is contributing 0% of alcohol. So we determine the amount of alcohol that the witch hazel, 14%. The witch hazel that contains 14% of alcohol, how much alcohol it is contributing to the final 5000 milliliter mixture. We also determine the amount of alcohol that the 95% alcohol solution is contributing to the solution. And we all know that boric acid is not contributing any alcohol at all, so that's 0 ml. When we add those up together, we get 1230 ml. It means then that the 5000 mixture will contain 1230 ml of alcohol. And we can find the concentration for that by just putting 1230 over 5000 times 100%. And that will give us the final concentration of alcohol in the 5 liters. Alright, so just to recap, alligation medial is going to allow you to determine what the final concentration of a particular ingredient will be when you're mixing different mixtures together of varying concentration of that ingredient, and you are able to now determine the concentration using alligation medial. So that means the concentration is never given. You have to determine it. Usually alligation medial is the arithmetic method that you're going to use. Of course, you're going to have to be combining different mixtures of varying concentration of an ingredient together. Alright, so I hope that you would have gotten quite a few of these questions correct. If you didn't, just review. Take this video and review. You are able to go back on Moodle to see where you went wrong and make sure you understand the concept. Don't try to swat the answers. It's not going to help. You need to understand where you went wrong and to know when to apply the concepts. Alright, thank you for listening, and we'll see you next time.